To start off, let's just look at some really simple exponential functions. So the one here in red is the one just called e to the x. And the one which is in blue is now e to the negative x. So if you look at the red and the orange together, the red and the orange, they are a reflection in the x-axis. And the orange now will be just a negative of that red one. So we will call it negative e to the x. And the same thing goes for the blue and the green. The blue is e to the negative x, and the green will be the mirror image in the x-axis. So we will call that one negative e to the negative x. And the reason I'm showing you this at the beginning is because the two functions that we have is one is e to the x negative 3, whereas the other one is g to the x 3 minus 5 e to the negative x. So I want to show you that the very first one in the function fx, we're dealing with ex, and for the second one, we're dealing with minus 5. The negative 5 is important because that's part of, or I should say it belongs to the e. So we're dealing with two types of functions here. One is going to be following the red line, and the other one is going to be following the yellow curve. And the red function, or the fx function, you'll see is going to be translated 3 down, whereas the this function here gx is going to be translated 3 up. And all this is just to show you a little bit about what's about to happen. In the E, you'll be actually asked to sketch the graphs of both functions, but we're not doing this at the moment. I'm just giving you a little brief description. So initially, we're just asked to look for the x and the y intercepts of both functions individually. So we're going to look at those. And so to find the x-axis, we're going to do, this only happens when y is equal to 0. So I'm going to write y is equal to 0 on both sides. That means that 0 is equal to e to the x negative 3. Work this one through, which means that e to the x is equal to 3. To find the value of x, I will ln both sides. So it'll be e to the x, and that's also ln 3. And remember that in this case, you'll find that ln e is just x, so x is equal to ln 3. If we want to find out the y-intercept, we'll have to make that x equal to 0. And so we will get, substituting 0 for x, and that's just ending up 1, take away 3, which means it's minus 2. And so our intercepts will be here, ln 3, and also this one here. And now to the gx function. So that's going to be 0 is equal to 3 minus 5 e to the minus x, 3 divided by 5. ln both sides, which is 3 over 5, equal to e to the minus x. Now there's a problem over here because I've got minus e, so I'm going to use the log law and put that e minus to the here. So I will have because once again our ln e disappears as these two. Okay, so pay close attention here, because as I move the minus to the other side so that I can have this as just plain x, that negative sign now that I have over here, I'm going to use one of the laws of logarithms and move it up to here, which means that I will have ln 3 over 5 to the negative 1, which is x. So this allows me to do a reciprocal 5 over 3, which is equal to x. So that my y-intercept is going to be x ln 3, 5 over 3. And one more step, so that when x is equal to 0, to find a y-intercept, we're going to have 3 minus, and that just leaves y equal to minus 2. Interesting, because so was the other function had the same intercept. And this information will help us to accurately draw the function where it intersects, because we already know that they are curved one way and curved the other way, but now we need to know where they intersect. Our B is to discuss the function fx and gx as x goes to infinity and as x goes to the negative infinity. To do that, let's just imagine a very scale, and on that side where numbers going, all the x's are going to infinity, to very positive high numbers, and on this part here the x's go to negative infinity numbers. And what is actually happening to the function as it goes up and down? Our function is ex minus 3. So now just pretend that in here you're going to substitute a really, really high number. Say, for instance, you want to say e to the 1,000 and so on, minus 3. What will e to the 1,000 be? It's a very, very large number. Very, very large. So you're looking at an extremely large number, and you're just going to take 3 away. So in the end, you are going to get a very large number here, positive number. And what you will actually write is, as x goes to positive infinity, then fx goes to positive also infinity. This is your answer to this question. Now let's have a look at the other side, where we've got the same function, e to the x minus 3, but we're going to make the x values really, really, really small. In fact, they'll be so small that you could say probably that they are negative numbers. Okay, so we'll put minus 1,000, take away 3. Now, if we can write this as 1 over e to the 1,000, okay, take away 3. Now, that e to the 1,000, we know that that is extremely large, so 1 over an extremely large number mean take away 3. This 1 over extremely large number will make this extremely small number, and you've got a very small number like 0, for instance, which will go tend to 0. So 0 take away 3 means that as our x values go to negative infinity, our function now goes to the negative 3. Okay, we'll separate this and work the same thing on this side. So we've got x going to a very high infinity and x going to a very low infinity, minus infinity. And our function this time is 3 minus 5e to the x, negative x. And as x goes to very, very large numbers, we will say that x goes to this minus 1000, make it, which means that this is really 5 over e to the 1000. So we're talking about an extremely small number. This becomes very, very, very small, because e to the 1000 is going to be 10 to 0. So we are going to be left with fx when x goes to really high infinity. Then we'll say that the gx, because we're dealing with gx now, tends to go to 3. And on the other side, we'll have x going to a very, very high negative infinity. So we'll get here a negative 1000, which was just going to make it into a positive 1000. And positive 1000 is really, really very, very high, very big number. This is going to be a huge number. And if you think of a 3 taking away a huge number, that means a number, then you're going to have a very huge negative number. That's what's going to happen. You're going to come up to with a very huge negative number. So in that case, we're going to now say that as x approaches the negative part, then the gx are going to approach at the negative infinity. Now to draw the sign diagrams of fx dash and f double dash x, we'll go to f dash x and just differentiate this. And our sign diagram will be positive for all values of x. And if we check f double dash x, then we'll find that's also e to the x. And our sign diagram will also be positive. What does that really mean altogether? It means that when fx is increasing, that means its slope is positive. F double dash is convex or smiley face. Okay, looking at our g function, the gdex is going to be 5e to the minus x. And that means our sign diagram is going to be positive. And g double x is going to be minus. So that means that our sign diagram for g double x is going to be minus, and it's all because of that minus sign here. And so we can conclude that when fx is increasing, because its slope is increasing, then f double dash is going to be concave or sad face. And now to solve algebraically the points of intersection, we just make those two equal each other. 3 minus 5 e to the minus x. So just rearrange. The trick is here to multiply by e to the x to make it a quadratic. And now just rearrange this so you can make it look like a quadratic. And now you should be able to factorize it. Just pretend it's x squared minus 6x plus 5. Now just translate this into ex minus 1 and ex minus 5. And let ex be equal to 1, and therefore ex is equal to 5. Therefore x is equal to 0, or x is equal to ln 5. And if you just substitute this into this first simple equation of EX minus 3, then we will just have 1 minus 3, which is equal to minus 2. Substitute ln 5 into that equation 2, and we have E ln 5 minus 3, and E ln disappears, so 5 take away 3, and we'll get 2. Our points of intersection are going to be 0 minus 2 and ln 5, 2. And now we just need to sketch the graph. We know that one intersection is going to be at 0 minus 2, which will be here. But to give me a clue where the second intersection is, I want to know what ln 5 in reality means. ln 5 is approximately 1.6, so we are looking at 1.6 and 2. I also know that fx approaches minus 3 and that the gx approaches 3. And we also established that the fx or ex has that shape, whereas gx will have the following shape. And so this answers all of the questions related to question 6.